Hello, welcome to this assignment explanation. I have created two separate repositories for both tasks. For task one, we have grocery net Angular, which is a grocery mini grocery systems, which uses net core as a backend and Angular as a front end UI. Second one is our inventory, which is an inventory allocation system, which uses Express as a backend, React as front-end web UI, and Flutter as a multi-platform web UI or application UI. Coming back to our code for task one, we have this folder structure, backend and frontend. We splits back server logic into backend and UI logic into frontend. For this, we will just focus on backend right now. So in the backend, as you can see, we have currently controllers, data, models, repository, and services. Data is just seeding data. For this example, models are the model of the system databases such as like order and its fields, products and fields. The system have the workflow such as that when user sends us request, the request is passed to the controller. Controller will assign the service for the request. The services will call repositories for fetching data or updating data. So now start from top. We have order controller and product controller. So product controller is just lister. So it just gives us a list of products in our repositories from database to the user. Order controller, it is our main business. In this controller, you can see uh, the database is post request access server access post request. This post request is sent to the controller, and controller will assign this service. Now let's go to the service. So the service is place order async. So it will place order asynchronously. Now as per requirement, we have only a single transaction for whole process. There is no triggers or any other things such as like what do you call it? Store procedures for this transaction for this whole process. We are only using a single transaction. As you can see in this transaction, we are starting a transaction and that transaction is completed at the very end. So first step is we are checking whether the product is available or not. So for let's assume there is a product C which user want to purchase, but there is no products in our database. It will throw this error that product is not found. Then there is a stock. This will ensure uh, uh, that we are not using or accepting over orders, such as like for some person order 80 of product one, but in inventory there is only 50 products. So it will throw that error that stock is insufficient and which will allow us to avoid negative inventory errors, such as like for as for this example, we have stopped the user from purchasing 80 from 50, creating minus 30 dollars in our inventory. So afterwards, if both conditions are successful, product stock will be decreased by amount of quantity order. New order is created. This product is up with respect to this new order. Once new order is created, this will update our product. So now our product will have changes in database suggesting that the product is purchased, like inventory is reduced. It will this will add a order to the database. Afterwards, this will save changes, current transaction changes into the transaction. It will check the transactions, and afterward, after if there is no error, whole process transaction will be completed, and our database will show the changes. So for database changes, we are using repositories. Uh, Repositories are solely responsible for any database changes. So service for like in this system, we are using controllers, models, and repository. Each model is responsible for certain things. Controller is only responsible for handling HTTP requests. Services are only responsible to handle business logic. Repositories to handle database and communication with database with application, and models which are used by these repositories to show to understand the schema from database and our internal structure from repository. So it just provides a structure for repository to communicate better with databases. Now coming to our application demo, is .NET DLL. Let's start our application now. So we have now this we have 50 stock of rice and 50 price of rice. Similarly, we have 20 and 40. Now we have database, which also shows the same thing. There is no order right now, and there is 50, 50, 40, 20. So now let's go and change. Let's order 30 rice per stock. We order 30. As you can see, the order is fulfilled. We have 20 stocks. Let's say in database. Now it shows us that there are 30 quantity and it is showing us a total price like 13 to 50, 1500. And it also reflect changes here. Now let's assume we want to put another 30 deliveries, 30 orders, but now stock is 20. So it shows a insufficient stock order error. So this allows us to not over purchase or do any other things like that. As you can see, there is no changes in database as well. There is bonus thing I did in this example. For example, now we have 20 stocks, we order 20. Now this thing is disabled. You can change or put any order. It's just small fail check on UI level. At the end, it is not. It doesn't require any communication from front end. And this is just to reduce any API uses when there is no product in stock at all. Now let's move on to our task 2. Let's just stop this please. So this is a task 2. As you can see, there are 3 folders: front-end, back-end, and app. App is multi-platform Flutter application. Back-end is our server, and front-end is a React. So in this example, I also did the same thing like previous. I have a controller, repository, models, services for each thing. Controller takes the orders from HTTP request, and it provides to the repositories, sorry, services. Services then use transactions to do do any changes in databases. So in this example, as you can see, our root is we are using order root. With this order root, we are there is only single API endpoint in this application as per task or requirement. So this order root is here, which is just create order post or request, which allows us to check if there is product ID or quantity is present in your database or not. data, not the database in request for every request. So if you have no you have empty product ready or empty quantity, it will throw the missing error, product ready or quantity error. Afterwards, if it's successful, there is data in both product ID and quantity. It will send it to the our service. But if there is any error other than this error, like from place order or any other error in this thing, it will just send us error messages as a 400 or internal server error if error message is not clear. So now coming back to our service, place order service. In our product service, there is place order. This place order will start a transaction. We are using SQLize ORM for this application. So it will fetch the product. If product is present, it will accept. Otherwise, it will throw not found error. If stock is less than quantity of item required by user, it will throw the insufficient stock error. If both conditions are failed, if there is product and product stock is sufficient, product stock will be subtracted by quantity to show new product amount. This product will be saved in transaction. Then new order is created, and once new order is created, transaction will be successful. Now coming back to our repository, where which is used by the transaction, you can see there is a transaction and there is a log. This log is used to avoid race conditions and add a concurrency. So let's say for example, you have two users, both user create a order, or stock which is 5 items, and user B and user A and user B created three items order. It will generate successful result for first user. Let's say user A click little bit earlier than user B. The user A will get success result as three orders are successfully placed, whereas user B will get insufficient order error. This is possible to fix this locking update. So this locking update allows us to only perform operation when the low is free. So it's like user one is doing something. User one's request is accepted, and now the user one's request have ownership over this current lock, current row at the moment. Until he doesn't, his row doesn't changes, his process isn't it completed, ownership won't be transferred to the next person. So this way it will avoid any race conditions or any issues such as negative stocks. Now coming back to our front end, actually I don't have emulator installed on my PC. I did testing on Android, so I can't show you direct test result or screen recording of Android application, but I can show you screen recording from this front end. So let's start. Before that, let's just go back to our server. I also forgot to mention this one. I actually did testing for this application. So in testing, we are using actually three tests. First one is should order successful or not. So for example, right now, if there is a by default, we are using 100 product 100 like this. We have 100 products. Actually, I'm not starting. Just let me start first. Okay, so we have item one, which is product ID one, and there is 100 in stock. So this is our starting thing right now. So let's see here. So we have order. We are ordering for a product one for 30 quantity. It should be successful, and the product quantity should be 61. This is our first test case to show the product is ordered correctly. The second test is we are now using another thing. We are calling 101 quantity, but our product is already 61 to do previous test. So it will throw us insufficient stock error, and it will show that there are only 61 products in inventory. There is no changes generated. Afterward, we'll go to this thing. Here, user is ordering 39. As you remember, there are only 61 items in our stock. Sorry, now there is we are updating. Sorry, yeah, we are updating the product manually here for better understanding for better clarification. So we have 100 products, and we are using first order as a 39 products, and on second order we are using 80. Now we are actually sending both requests at a similar time, but here we can see the order one, order two are slide in order. So it will just successfully one of the order whichever completes first will have successful result, whereas unsuccessful will get insufficient order error, and it will have a status as 400. So as you can see, there is to be only one success order, only one failure order. At the end product will be one, and our first one will be successful. There is a space. As you can see, both tests are passing. As you can also see, there is you can visually see like first test is successful, second test is successful. Then there is another two orders. Now let's go back to our content. Let's start this process and our application. As you can see, you have to. So now let's just put empty things here and place order. It will show the order not found. Now one and create order. It are showing us this thing is successful because right now we don't have any checks on front end as per requirement for putting 0 or 1 value name order values. Let's check our orders, new orders here. Quantity 0, confirm. There is no changes here, and as you can see, there is no change here. Now let's put 10 products here, and let's order 90 products. It should throw error that product not found because there is no product ID of 10. Now just let's put 1 and 90. Order is successful. Now let's check database or database. New stock is 10 and our order is 90. Now let's put another 90 order. It will show us error that is insufficient stock. So it is actually providing us error that the stock is the order cannot be fulfilled directly. So this was main thing for both tasks. This was explanation of both codes and simple walkthrough. These implementations actually prioritize our correctness, atmosity, and explainability of the system. So these systems can be easily explained, expl- can be easily expanded in future. We can add another routes, another endpoints for better UI. Every design decision is actually intentional due to constant listening tasks requirement, and it aligns with requirements and the responsibilities on backend. So the error request, etc., are actually handled uh, clearly. Thank you.